Chapter 3: Functional Programming with JavaScript. When you start to explore the world of React programming, you'll notice that the topic of functional programming comes up a lot. Functional techniques are being used more and more in JavaScript projects. You may have already written functional JavaScript code without thinking about it. If you've mapped or reduced an array, then you're already on your way to becoming a functional programmer. React, Flux, and Redux all fit within the functional JavaScript paradigm. Understanding the basic concepts of functional programming will elevate your knowledge of structuring React applications. If you are wondering where this functional trend came from, the answer is the 1930s, with the invention of lambda calculus. Or calculus.1 functions have been a part of calculus since it emerged in the 17th century. Functions can be sent to functions as arguments or returned from functions as results. More complex functions, called higher-order functions, can manipulate functions and use them as either arguments or results or both. In the 1930s, Alonzo Church was at Princeton experimenting with these higher-order functions when he invented lambda calculus. In the late 1950s, John McCarthy took the concepts derived from calculus and applied them to a new programming language called Lisp. Lisp implemented the concept of higher-order functions and functions as first-class members or first-class citizens. A function is considered a first-class member when it can be declared as a variable and sent to functions as an argument. These functions can even be returned from functions. In this chapter, we are going to go over some of the key concepts of functional programming, and we'll cover how to implement functional techniques with JavaScript. What it means to be functional. JavaScript supports functional programming because JavaScript functions are first-class citizens. This means that functions can do the same things that variables can do. S6 adds language improvements that can beef up your functional programming techniques, including arrow functions, promises, and the spread operator chap. Tier 2. In JavaScript, functions can represent data in your application. You may have noticed that you can declare functions with the var keyword the same way you can declare strings, numbers, or any other variables. Var log equals function message. Console.log message. Log in JavaScript functions are variables. // in JavaScript, functions are variables with S6. We can write the same function using an arrow function. Functional programmers write a lot of small functions, and the arrow function syntax makes that much easier. Const log equals message equals console.log message. Since functions are variables, we can add them to objects. Const obj equals message. They can be added to objects like variables, log message, console.log message, obj.log obj.message, // they can be added to objects like variables. Both of these statements do the same thing. They store a function in a variable called log. Additionally, the const keyword was used to declare the second function, which will prevent it from being overwritten. We can also add functions to arrays in JavaScript. Const messages equals. They can be inserted into arrays, message equals, console.log message. Like variables, message equals, console.log message. Messages 1, messages 0 // they can be inserted into arrays. Messages 3, messages 2 // like variables. Functions can be sent to other functions as arguments, just like other variables. Const inside fn equals logger equals logger. They can be sent to other functions as arguments. Inside message equals console.logMessage // they can be sent to other functions as arguments. They can also be returned from other functions, just like variables. var create screen equals function logger. Return function message. Logger message.uppercase. Const screen equals create screen message equals console.logMessage. Screen functions can be returned from other functions. Screen create screen returns a function. Screen invokes that returned function. // functions can be returned from other functions. // create screen returns a function. // screen invokes that returned function. The last two examples were of higher order functions that either take or return other functions. Using S6 syntax, we could describe the same create screen higher order function with arrows. Const create screen equals logger equals message equals logger message.uppercase. From here on out, we need to pay attention to the number of arrows used during function declaration. More than one arrow means that we have a higher order function. We can say that JavaScript is a functional language because its functions are first-class citizens. This means that functions are data. They can be saved, retrieved, or flow through your applications just like variables. Imperative versus declarative functional programming is a part of a larger programming paradigm. Declarative programming. Declarative programming is a style of programming where applications are structured in a way that prioritizes describing what should happen over defining how it should happen. In order to understand declarative programming, well, contrast it with imperative programming, or a style of programming that is only concerned with how to achieve results with code. Let's consider a common task: making a string URL friendly. Tip I. Cowley. This can be accomplished by replacing all of the spaces in a string with hyphens, since spaces are not URL friendly. First, let's examine an imperative approach to this task. Var string equals this is the midday show with Cheryl Waters. Var URL friendly equals. For var I equals 0, I. Dot length, I. If string I equals URL friendly equals dash. Else. URL friendly equals string I. Console.log friendly. In this example, we loop through every character in the string, replacing spaces as they occur. The structure of this program is only concerned with how such a task can be achieved. We use a for loop and an if statement, and set values with an equality operator. Just looking at the code alone does not tell us much. Imperative programs require lots of comments in order to understand what is going on. Now let's look at a declarative approach to the same problem. Const string equals this is the midday show with Cheryl Waters. Const URL friendly equals string dot replace / g dash. Console.log friendly. Here we are using string.replace along with a regular expression to replace all instances of spaces with hyphens. Using string.replace is a way of describing what is supposed to happen. Spaces in the string should be replaced. The details of how spaces are dealt with are abstracted away inside the replace function. In a declarative program, the syntax itself describes what should happen and the details of how things happen are abstracted away. Two additional details about the declarative programming paradigm can be found at the declarative program. MingWiki. Declarative programs are easy to reason about because the code itself describes what is happening. For example, read the syntax in the following psalm plate details what happens after members are loaded from an API. Const load map members equals compose. Combine white session storage, members, save session storage, members, scope members window, log member info to console, log fields to console name dot first. Count members by location dot state, prep states for mapping, save session storage, map, render as map. Get for ke members 100 dot then load and map members. The declarative approach is more readable and, thus, easier to reason about. The details of how each of these functions is implemented are abstracted away. Those tiny functions are named well and combined in a way that describes how member data goes from being loaded to being saved and printed on a map. And this approach does not require many comments. Essentially, declarative programming produces applications that are easier to reason about, and when it is easier to reason about an application, that application is easier to scale. To. Now, let's consider the task of building a document object model, or DOM. An imperative approach would be concerned with how the DOM is constructed. Var target equals document.getElement via target. Var wrapper equals document.createElement div. Var headline equals document.createElement h1. Wrapper.id equals welcome. Headline.innerText equals hello world. Wrapper.append child headline. Target.append child wrapper. This code is concerned with creating elements, setting elements, and adding them to the document. It would be very hard to make changes, add features, or scale 10,000 lines of code where the DOM is constructed imperatively. Now let's take a look at how we can construct a DOM declaratively using a React component. Const render equals React DOM. Const welcome equals hello world. Render / document.getElement via target. React is declarative. Here, the welcome component describes the DOM that should be rendered. The render function uses the instructions declared in the component to build the DOM. Abstracting away the details of how the DOM is to be rendered, we can clearly see that we want to render our welcome component into the element with the ID of target. Functional concepts. Now that you have been introduced to functional programming, and what it means to be functional or declarative, we will move on to introducing the core concepts of functional programming: immutability, purity, data transformation, higher order functions, and recursion. Immutability: to mutate is to change, so to be immutable is to be unchangeable. In a functional program, data is immutable. It never changes. If you need to share your birth certificate with the public, but want to redact or remove private information, you essentially have two choices. You can take a big Sharpie to your original birth certificate and cross out your private data, or you can find a copy machine. Finding a copy machine, making a copy of your birth certificate, and writing all over that copy with that big Sharpie would be preferable. This way you can have a redacted birth certificate to share and your original that is still intact. This is how immutable data works in an application. Instead of changing the original data structures, we build changed copies of those data structures and use them instead. To understand how immutability works, let's take a look at what it means to mutate data. Consider an object that represents the color lawn. Let color lawn equals title lawn, color 00FF00, rating 0. We could build a function that would rate colors, and use that function to change the rating of the color object. Function rate color rating. Color.rating equals rating return color. Console.log rate color lawn 5.rating // 5 console.log color lawn.rating // 5 in JavaScript. Function arguments are references to the actual data. Setting the colors rating like this is bad because it changes or mutates the original color object. Imagine if you tasked a business with redacting and sharing your birth certificate and they returned your original birth certificate with black marker covering the important details. You'd hope that a business would have the common sense to make a copy of your birth certificate and return the original unharmed. We can rewrite the rate color function so that it does not harm the original goods, the color object. Var rate color equals function color rating. Return object dot assign color rating grating. Console.log rate color lawn 5.rating // 5 console.log color lawn.rating // 4 here. We used object.assign to change the color rating. Object.assign is the copy machine. It takes a blank object, copies the color to that object, and overwrites the rating on the copy. Now we can have a newly rated color object without having to change the original. We can write the same function using an S6 arrow function along with the S7 object spread operator. This rate color function uses the spread operator to copy the color into a new object and then overwrite its rating. Const rate color equals color rating equals color rating. This emerging JavaScript version of the rate color function is exactly the same as the previous one. It treats color as an immutable object, does so with less syntax, and looks a little bit cleaner. Notice that we wrap the returned object in parentheses with arrow functions. This is a required step since the arrow can't just point to an object's curly braces. Let's consider an array of color names. Let list equals title rad red, title lawn, title party pink. We could create a function that will add colors to that array using array.push. Var add color equals function title colors, colors.push title. Return colors. Console.log add color glam green, list.length // 4 console.log list.length // 4. However, array.push is not an immutable function. This add color function changes the original array by adding another field to it. In order to keep the colors array immutable, we must use array.concat instead. Const add color equals title, array equals array.concat title. Console.log add color glam green, list.length / for console.log list.length / 3 array.concatenates arrays. In this case, it takes a new object with a new color title and adds it to a copy of the original array. You can also use the S6 spread operator to concatenate arrays in the same way it can be used to copy objects. Here is the emerging JavaScript equivalent of the previous addColor function. Const addColor equals title, list equals list, title. This function copies the original list to a new array and then adds a new object called tying the color's title to that copy. It is immutable. Pure functions. A pure function is a function that returns a value that is computed based on its argv.